So one of the things that helps us to simplify algebraic expression is using that property called distributive property. And we have learned in the order of operations that whenever we try to simplify something, we have to follow an order. What's the first thing we do in order of operations?
Parentheses.
Parentheses. Okay. And then what do we do after parentheses? Exponents. And then what do we look for after we've taken care of those things? Multiplication or division from left to right. Yeah. One isn't more important than the other. We just start at the left and work our way across doing any multiplication or division. And then lastly, what's the last thing we look for?
Addition and subtraction.
Addition and subtraction from
Left to right.
left to right. Okay. So what happens is sometimes when there's parentheses in a problem, inside those parentheses are some terms that cannot be put together. They're not like terms, and so we can't get rid of the parentheses by just, combining what's inside the parentheses and saying, okay, get rid of them now. So what we have to do instead to get rid of the parentheses is we have to do some multiplication over the terms that are inside of it. So if whatever is being added or subtracted inside those parentheses aren't like terms, we can't put them together. We're going to have to use multiplication to get those parentheses out of there. So this hopefully will look a little bit familiar. We have to take this 3 that's outside the parentheses, and because n and 4 are not like terms, we can't put those together and say we have 4n or n4. So what we're going to do is we're going to take the 3 times each of the pieces inside there. So let's show that. We're going to take 3 times n plus, bring our plus sign down that's inside those parentheses. We're getting rid of the parentheses. We're going to take 3 times 4. And yes, you need to show me this. Yes, you need to do this right now in your notes. Okay. And what is 3 times n?
That's 3n.
That's 3n. And 3 times 4, class is?
12.
12. Cody's got his voice going today. The rest of us haven't found ours yet. 3n plus 12. Okay, do you think there's anything else we can do? We always look to see if we can clean it up. Is there anything else we can do? In other words, do you think we can put that 3n and that 12 together now?
Yes.
Why?
Because they're on 2 separate sides of the variable.
Okay, because they're on 2 separate sides of the variable. Because the 3 is on the left side of the n and the 12 is on the right side, they should be able to be put together? No. Think of it like, okay, go ahead, Julia.
You can divide the 3 into 12.
You can divide the 3 into 12. Okay, but if we do that, guess what it'll actually do? If we say, you know what, both 3n and 12 are divisible by 3, you know what would happen? We couldn't just eliminate that 3 because we can't do it to another side. We can't do it to another side of an equation. And we're not within a fraction where we can do it upstairs and downstairs. So what would happen is if we did that, if we divided, we'd end up back here. Back to where we started. That's where we'd end up. If we divided by 3, we just end up back where we started. So the dividing, which is undo the property, we just applied.
Yeah.
So
Add 3 to 12.
can we add 3 to 12 and make it 15n? What do you think? How many of you think we can? Go ahead, raise your hand. Just you, Cody? And Jessie's thinking about joining me, but she's not sure. They like terms, you guys. Are n's like constants? No, they're not. So this is as good as it's going to get. This is the only thing we can do. It's as good as it's going to get. We got rid of the parentheses, though. Feeling good about that. We did do something. Okay, you try the next one on your own then. Simplify the next expression. This is still an expression, no equal sign in it. It's algebraic, it's got an x in it. Anybody out there want to agree with what I got? Just about that, everybody. Okay. Now, when I did the multiplication, notice how I put some like rectangles around them? Sometimes it's just a way of showing so that everything just doesn't look like a run-on. You can show, I'm doing the multiplication of -4 times each of those pieces. So I have 2 pieces in the parentheses, so I have 2 multiplications to do. And then when I'm done, I decide, could I do any more? This one can be cleaned up. We're going to clean this up. This is not how. On the math test tomorrow, you have to do something like this. Let's say on a problem. That answer would not be in the answer bank. Well, I'm pretty convinced we're right, though. Are you pretty convinced we're right? Well, then why wouldn't this answer be in the answer bank? Any ideas? Because it's not going to be, I promise you. I promise you we have the right answer, but I promise you that if this problem was on the test tomorrow, this would not be in the answer bank, most likely. So then what are you going to do? You're going to just say, oh, well, I guess I didn't get the thing I thought it was, so I'll just take a guess. I'll take the one that looks the best. Is that what we do? No, we clean it up. This needs to be cleaned up. So would you put that there? Clean it up. That's what I call it when I am not happy with that answer, or I say to you, you know what, that's not going to be in the answer bank. Clean it up. Just like we can change subtraction to add the opposite, what do you suppose we can do with addition? Or with addition. We can change subtraction to add the opposite. So what do you think we can do with addition? Subtract the opposite. We can do the same thing in the reverse order. So we would leave -8x, -8x. We don't change that. We never change the first term. We change the addition to subtraction, and we say, what's the opposite of -8? 8. This is the one we want to circle. That's how we would see it in the answer bank. -8x, take away 8. Now notice what really happened here. In the process of cleaning up, you could say to yourself, here's what really just happened. I just have to do what? Well, to clean it up, what can I just say to myself? Abby?
Make the addition subtraction.
Yeah, take the addition sign out of there and make that subtraction, right? Pull that over and let that be a subtraction sign instead. So we have to know that this means the same thing as it did over here, but we have to know how to clean that up.
So is that what you do every time?
So every time, I always want you to practice cleaning up your answers. Now, I should be really careful about that when Jessie says, do we do that every time? We only do it when there are what I call double signs. See these double signs right here? They're right beside each other. Whenever there's double signs, that's when we need to clean it up. Because notice, we didn't clean up the answer above, did we?
No.
We didn't clean that one up. How come we didn't clean that one up?
It was already positive.
Yeah, it was just a plus sign. There were no negatives involved there. There were no double signs. So we did not need to clean that one up. This one we had to clean up because of those double signs there. Okay. The next one is kind of tricky, and students typically don't do well with these, and this is what I'm going to make you do. I'm not giving you any choices here, okay? Because you've already proven to me so far this year that we've been too calculator dependent. We let the calculator do all our multiplying and adding and subtracting and everything pretty much for us. And we have not really figured out how to work with negatives properly. So here's the first thing we're going to do. When there is not a number in front of the parentheses, what number can we multiply by that won't change the value? In other words, we won't be renaming the problem to a different value. 1, yeah. So we're going to rewrite that first of all, say, I can change that to, I can slip that 1 in there. Okay? And I want you to show just this step. We're going to do things one at a time here to show ourselves what we did. Okay, then the next thing we're going to do is because there's subtraction in that problem, we're going to change it to add the opposite. Okay? So I'm going to take, that -1's going to stay -1. That 5's going to stay 5. But I'm going to change, The other thing we're going to do is we're going to slip a 1 in front of that y. I'm sorry. Slip a 1 in front of the y there too. When there's not a number in front of the variable, we can put a 1 in there. Now we're going to change our subtraction here to addition, and we're going to ask ourselves, what's the opposite of 1y? Negative 1y. Okay. So in the first step, we inserted some 1s in those places where they were invisible, where we could. So there was nothing in front of here in between that negative sign and the parentheses, so we slipped a 1 in there. There was nothing in front of this y, so we slipped a 1 in there. Now we changed it to an addition problem, add the opposite, and now we're going to do our multiplication. We're going to take negative 1 times the 5. So here's one of my multiplications, plus negative 1 times negative 1y. There's my other multiplication. Negative 1 times 5. Negative times a positive? Negative. 1 times 5? 5. Negative 5. Negative 1 times negative 1y. Negative times a negative is a positive. 1 times 1 is 1. So we have 1y. Do you think they're going to leave it like that in the answer bank?
Yeah.
What are they going to do? They're going to clean this one up too. And I'm not trying to confuse you. There's no double signs, are there? That's not what we're going to clean it up with. Here's what's another way that they might show 1y in an answer bank?
Y.
Just as y. So chances are they would show this as this, like that. They get that 1 out of there because they say, you know what, just like you can put 1 in there, multiply by 1, or divide by 1, you can take it back out again. So we have to know that, you know what, sometimes we think we're wrong, but we just haven't cleaned up our answer. We have the same answer as they do, we just don't realize it. Okay, what do you think I want you to do first in number 4? Before, I'm going to give you a little hint, before you multiply. Julia, what's one thing you think I might want you to do?
Put a 1 in front of the x.
Put a 1 in front of the x, okay. Oops, we don't do it in that step. Where am I doing it there for? I don't know. Okay, so we're going to put a 1 in front of the x, okay. And
Plus negative 1.
and then we could also change it to add the opposite. So you could do this all in one step, but maybe in our notes we will show it as a couple. So here we just inserted a 1, and now we're going to change that subtraction to addition, and the opposite of 1 is negative 1. And now we're ready to multiply. So go ahead and do this one. See if you can get your answer cleaned up the way you think I'm going to, proclaim it should be. Because I'm like the test tomorrow. Or any other day. Notice we don't use the multiplication symbol anymore. We're in algebra now. We don't want it confused with the variable. Calvin, what do you have after you did your multiplication?
Negative 3x plus negative 3.
Okay, so after the multiplication, I agree with you. How many of you agree with Calvin? You did good multiplication? Okay, so are you done, Calvin, with that problem? Would you say we're done? No? Okay, how many of you agree with Calvin? This isn't done. This isn't how we're going to see it in an answer bank. Okay, how would it look cleaned up then? No, I'm going to pick on you next. How would it look cleaned up?
Negative 3x minus 3.
Negative 3x, that stays like it is. Subtract 3. Yeah, there we go. We got rid of our double sign. But unless I tell you in the directions you have to clean up on a quiz, let's say, give me cleaned up answers, I wouldn't be able to count the blue answer wrong because you did it right. But again, I'm just saying to you, like, I don't want you to be taking a multiple choice test, work through a problem, and then you're like, bummed out because there's 4 answers and not one of them looks like yours. I want you to know that you really do have one of those answers. You just have to get it to look like that correctly, legitimately. Okay, let's go to the back side. The other type of thing that we can do, it says, to simplify algebraic expressions in our learning goal is we can simplify them by combining like terms. Okay? So, when we talk about combining like terms, we're talking about terms that are constants, because if they're constants, they're like terms. 3 can be added to 6, negative 2 can be added to 1.5. Those are constants, they're like terms. They can be put together. Or terms that have the same variable part. So as long as they have the same, they have a variable, and that variable is the same, then we should be able to consider them like terms. Okay? So, number 5 here. Again, I'm gonna insist this is what we do because I find out students are far more successful. We're gonna change subtraction to add the opposite first. That's gonna be our first move. We have 1 subtraction in this one. So it's gonna become 4x what? Plus negative 1, and then we don't have to do anything with that other addition. Now notice we're not changing the addition, just the subtraction. Okay, what can I slip in front of that x? A 1, okay? Now, you can either rearrange the terms, which I'm going to guess this won't probably happen much because we love to save on lead, or you can do something like maybe a teacher taught you along the way, when you're combining like terms, maybe you could circle the ones that could be put together. So we got some 4x's at the beginning, we got a 1x at the end, we got all this addition going on, we can bring them together, can't we? Okay, if I have 4x plus another 1x, what do I have? 5x. 4 plus 1, they were x's. When we added them together, they're going to stay x's. Dollars added to dollars, still are dollar bills in the end, in the pile in the end. Plus that negative 1, that constant doesn't have anything to be combined with. Are we done?
Nope.
What do we have to
Change
do?
it to 5x.
Yeah, we want to clean it up yet. 5x, subtract 1. We got that double sign going on there. Okay, you do number 6 now. First move you have to make is change subtraction to add the opposite. Let me say it again. First move you have to make is change any subtraction to add the opposite. Okay, first of all, we gotta know how to change to add the opposite correctly. We have to make sure we're doing that part accurately. So we change to add the opposite. We don't just change the subtraction sign to an addition sign and copy everything else down. We have to ask ourselves, what is the opposite of 4y? It's negative 4y. What's the opposite of 3? It is negative 3. Okay, now because we have constants and variable terms involved in this one, what could I consider to be like terms in this expression? Cody, what's one set of like terms?
Adding the positive 2 and the negative 3.
Okay, the positive 2 and the negative 3 are like terms because they're constants. What else could I consider like terms in here? Jossie? The negative 4y and the 2y. Okay, so we have, whenever it's all addition, this is what we can do. So we have 2 plus negative 3, negative 1, plus,
Negative 2y.
we have a negative 4y, a positive 2y, that's a negative 2y. You owe somebody $4, you pay them back 2. You're not owing them money yet, you still owe them $2, don't you? Okay, is this how we're going to see our answer? No. Negative 1, subtract 2y. Okay. Now, we didn't do this on the front side or on a different one, but I want you to also know there's another way we would see this answer in an answer bank. What if it's not this one? You've cleaned it up and now it's still not that. You're like, what in the world do they want from me? I did it right. Cody?
Can't you change the 1 to a positive 1 and make the negative and keep it 1 plus negative 2y?
No, that we can't do. We can't just let that 1 in the beginning change to a... But what can we do in addition? What does addition allow the terms to do?
Switch.
Switch places. They can switch places. So this could be rewritten as negative 2y is going to trade places with the negative 1. So show that in your notes, because this is another thing we have to say. What if I get this answer and it's not there? So because these two can trade places, I have them switch up. Notice they didn't change signs or anything. They just traded places, and now I clean it up. Negative 2y minus 1. So, or we can have this answer either way. And sometimes they like the variable term to be first and the constant to be tagging along. So we just gotta know all this stuff. We don't know how they're gonna put it in the answer bank. We have no idea, but we have a good answer 3 different times. They all are right, but which answer is, what's the way they're gonna give it to us? We have to know that. Anybody have questions at this moment before we go where we have to do both of them within an expression? We have to do some distributive property and combined term. No? Okay. And let's try that last one. I think it's just one more, isn't it? Okay. Well, what do you suppose, before we even do distributive property or combining like terms, I'm going to tell you that we're going to do? Add the opposite. Absolutely. That's what we're going to do first. So we're going to say, I have the 5, the parenthesis, I have the 2x, and now I'm going to see that subtraction. I'm going to say, I'm going to change that to add what?
The opposite.
What is the opposite? Negative 3. We were subtracting 3. Its opposite is negative 3. Now we put our parenthesis there. What's this? Is that a subtraction? That's a subtraction, so we're going to change it to add. And again, we have to do the opposite of 10. Negative 10. Okay. What do you suppose we should try next now? Yeah, remember what the order of operations says? Order of operations says take care of parentheses. Well, we're going to take care of them. We can multiply. So we're going to take 5 times 2x, and we're going to take that 5 times that negative 3. And then we're going to bring down along our tag along, the negative 10. I call those tag along, because they're not part of the multiplication. That's not in those parentheses. It doesn't get multiplied by the 5. It's, you know, it's like a bestie little brother or sister tagging along with you. You go to Dairy Queen and get ice cream, but you don't give them any. They didn't get the 5, okay? Only the other, you and your friend did. Okay, so now we're going to do that multiplication. What's 5 times 2x? 10x. Plus negative 15 plus negative 10. The tag along still comes along. Tori, do we have any like terms? Because we did our distributive property. Now we're asking ourselves, do we have any like terms? What are they? The negative 15 and the negative 10 are like terms. So that means we can bring them together And so we bring now the 10x is turned into the tag along. It doesn't have anything to be put together with.
Negative 25.
Negative 25. Borrowed $15 from your older sister, then you borrowed another $10, and now you owe your older sister $25. Is that how we're going to see the answer in the answer bank? Devontae, how are we going to see it?
10x minus 25.
10x subtract 25. That's right. Okay. So we're practicing simplifying to get ready for solving equations that are going to have to be simplified first before we can actually go about solving them. So we're just simplifying expressions to get the practice. Okay? Questions? Okay. Go ahead.